NASA Moon Mission 2026 marked the first crewed journey around the Moon in more than 50 years. This mission, known as Artemis II, was carried out under the Artemis program led by NASA. Its primary goal was to test whether humans can safely travel to deep space and return before attempting a lunar landing. It also represented a major step toward re-establishing a human presence beyond low Earth orbit. Before we continue, take a second to like the video, drop a comment, and subscribe to our channel for more clear and fact-based space updates. And make sure you watch till the end, because the final part of this mission explains why it was so important for future moon landings. Artemis II followed several years of preparation, including the uncrewed Artemis, the first mission which tested the Orion spacecraft systems. The crewed mission built on those results by placing astronauts on board for a full, deep space flight. The mission included 4 astronauts who traveled farther from Earth than any humans since the Apollo era. This allowed NASA to validate real-world human performance in deep space conditions. The mission began with the launch of the Space Launch System rocket from Kennedy Space Center. This launch followed multiple delays due to technical checks, including hydrogen leaks and safety verifications. At liftoff, the rocket generated massive thrust from its core engines and solid rocket boosters. Within minutes, it cleared Earth's atmosphere and successfully entered orbit. Once in orbit, the Orion spacecraft separated from the rocket and began its journey toward the Moon. The spacecraft then entered a trans-lunar trajectory, traveling through deep space over several days. During this phase, the crew continuously monitored onboard systems such as navigation, environmental controls, and communications. This portion of the mission was critical for testing how astronauts operate beyond Earth's protective magnetic field. As the spacecraft moved farther from Earth, it reached distances exceeding those achieved during the Apollo missions. This placed the crew in deep space conditions for an extended period, exposing them to higher levels of radiation. Data collected during this phase will be used to improve safety for future missions. It also helped validate the Orion spacecraft's shielding and life support capabilities. When the spacecraft approached the Moon, it did not attempt a landing. Instead, Artemis II performed a lunar flyby, looping around the Moon before heading back to Earth. This trajectory allowed NASA to test navigation, propulsion, and timing under real mission conditions. It also provided an opportunity to observe and study the Moon from a crewed spacecraft once again. A key moment in the mission occurred when the spacecraft passed behind the far side of the Moon. This region never faces Earth and blocks all direct communication signals. During this time, the crew experienced a planned communication blackout lasting several minutes. This phase confirmed that systems would continue operating normally, even without contact with mission control. While in lunar orbit, the crew captured high-resolution images and collected data on the Moon's surface. They observed the far side of the Moon, which is less studied than the near side. The surface showed extensive cratering and geological features that differ from what is visible from Earth. These observations contribute to ongoing research into the Moon's formation and history. The mission was considered successful overall, although a few minor issues were reported. One issue involved a malfunction in the onboard toilet system, which required temporary adjustments. There were also small technical glitches with onboard equipment, but these were resolved during the mission. None of these issues posed a significant risk to the crew or mission objectives. After completing the flyby, the spacecraft began its return journey to Earth. The return trajectory was carefully calculated to ensure a safe re-entry angle. As the spacecraft approached Earth, the crew prepared for one of the most demanding phases of the mission. This included ensuring all systems were ready for high-speed atmospheric entry. During re-entry, the Orion capsule entered Earth's atmosphere at speeds of approximately 25,000 miles per hour. At these speeds, intense heat built up around the spacecraft due to atmospheric friction. Temperatures reached several thousand degrees, testing the effectiveness of the heat shield. A temporary communication blackout occurred again due to plasma forming around the capsule. As the capsule slowed down, a series of parachutes deployed to reduce its speed. These parachutes were critical for ensuring a controlled and safe descent. The spacecraft then completed a planned splashdown in the Pacific Ocean. Recovery teams were already in position and successfully retrieved the crew shortly after landing. This mission demonstrated that modern spacecraft systems can safely carry humans to the moon and back. It validated key technologies including life support systems, navigation, communication, and heat shield performance. These results are essential before attempting a crewed lunar landing. Artemis II served as a full systems test under real mission conditions. The next phase of the Artemis program is Artemis II, which aims to land astronauts on the moon. This mission is expected to target the lunar South Pole, an area of significant scientific interest. Future missions may also focus on establishing a long-term human presence on the moon. These efforts are part of broader plans to prepare for missions to Mars. Overall, Artemis II was not designed to land on the moon, but to prove that humans can return safely to deep space. The mission successfully met its objectives and provided valuable data for future exploration. It marked a significant milestone in modern spaceflight. Based on these results, NASA is now closer to sending astronauts back to the lunar surface and continuing human exploration beyond Earth.